Hi dear students, welcome to today's class. Today we discuss two important phenomena related to solid gas equilibria. So far we were discussing various types of systems coming under solid liquid equilibria, and now we have solid gas equilibria, which is not very common, and we have only to discuss two important phenomena coming under this section. One is deliquescence and the other is efflorescence. Which are the cases of such system where solid and gas exist in equilibrium? For example, suppose a gas dissolves in a solid, or you are familiar with certain gases get adsorbed on the surface of metals, or it can be chemical combinations like a salt absorb moisture and form salt hydrate, or it can be a metal oxide absorb carbon dioxide from atmosphere forming metal carbonates, etc. Now coming to the two phenomena, starting with deliquescence. A related term is hygroscopic. What is the difference? A substance which has a tendency to absorb moisture is said to be hygroscopic, and deliquescence is the extreme case where the substance absorbs moisture continuously from atmosphere and eventually dissolve in it. You have a very common experience in your daily life, like soap when kept open. Many soaps, they absorb moisture and turn into paste like. Or in the lab you have a very good experience that when you keep sodium hydroxide pellets open in air, after some time you will see it turn into a paste like mass and finally it dissolves because NaOH is deliquescent. Soap is also, mostly sodium potassium salts. It also has the same property. So deliquescence is the phenomena in which a substance when exposed to atmosphere continuously absorb moisture and eventually dissolve in it to form their unsaturated solution. Examples are some chlorides like calcium chloride, magnesium chloride, hydroxides like NaOH, KOH, nitrates like copper nitrate, sodium nitrate, etc. are all deliquescent. Now let's understand the principle behind this. What is the reason behind deliquescence? This happens when pressure of water vapor in the atmosphere is greater than the vapor pressure of its means the substance saturated solution at the given temperature. In other words, if the substance under consideration has its vapor pressure of its saturated solution is lower than the vapor pressure of water in the atmosphere, or what we call aqueous tension, then only deliquescence happens. That means, for example, let's see, we have a deliquescent substance in this beaker. For example, it is NaOH solid. In the atmosphere, there is water vapor, and this vapor pressure of water is more than the vapor pressure of the saturated solution of NaOH. That means you take a saturated solution of NaOH, it has very low vapor pressure compared to the vapor pressure of water in the atmosphere. Suppose if this is a solution of NaOH, its vapor pressure is very less compared to the vapor pressure of water in the atmosphere. So naturally, water vapor will come to the solution, or solution will absorb water vapor for to equilibrate, or for equilibrium to achieve. So more water vapor will come down and the solution become dilute and it become unsaturated. Until that, it continues to absorb water vapor. So in effect, NaOH has a tendency to absorb water vapor from atmosphere. This happens when the atmosphere is humid. So the atmospheric condition is also important. Only when there is sufficient water vapor in the atmosphere, then only this deliquescent substance can absorb moisture and eventually dissolve in it. Right? So this is what is called deliquescence. So deliquescent substance has a property that it is highly water soluble. Then only it will be deliquescent, because when NaOH is put in water, it readily dissolves. So what happens? According to colligative property concept, when a solute dissolves in a solvent, vapor pressure will lower. So that's why it happens. So the substance is highly soluble in water, so that it has very low vapor pressure. Naturally, aqueous tension above the surface will be more, so it has tendency to absorb water vapor. So deliquescence does not happen in dry atmosphere. That I told you, if there is no water vapor in the atmosphere, it cannot absorb. So deliquescence happens in moist atmosphere, or it doesn't happen in dry atmosphere. Now on to the second phenomena, opposite of this, that is efflorescence. The phenomena in which a crystalline substance, a crystalline salt hydrate, when exposed to atmosphere, gradually lose their water of crystallization. It give out the water of crystallization, and it become a lower hydrate, or finally anhydrous. Again, you have a daily experience. See, when certain walls which is plastered with cement, you can see in the long run, you can see some powders appearing on the wall. It is because the cement loses its water of hydration, because during setting of cement, it is process of hydration. So it can lose water of hydration and it can become anhydrous. Then when a salt hydrate which is crystalline loses water of crystallization completely and become anhydrous, it will turn into a fluffy powder. That's why some powder like substance appear on such walls. So in efflorescence, a salt hydrate which is crystalline loses water vapor or water of crystallization and become either lower hydrate or finally anhydrous. So the crystalline substance may change into powder like substance. You can see in the lab again an experience. If you check hydrated sodium carbonate, if you take washing soda and leave it in dry atmosphere, it will lose water of crystallization and finally become anhydrous, and it will change into powder like substance. Another example is sodium sulfate 10H2O, magnesium sulfate 7H2O. These are all efflorescent substances. So efflorescence is the phenomena in which a crystalline salt hydrate, when exposed to atmosphere, gradually lose their water crystallization to change into lower hydrate or anhydrous. Now let's see the principle of efflorescence, why this happens. Similar to the case of deliquescence, what happens here? It happens when vapor pressure of the hydrate is greater than the pressure of water vapor in the atmosphere. That means, suppose you have this substance, efflorescent substance taken in a beaker and exposed to air, or you have a saturated solution of this substance. The thing is that its vapor pressure is higher, it is more, right? It has high vapor pressure, maybe because it is not very soluble in water. You can see that such substances are not very soluble in water, so it will have high vapor pressure. Whereas in the atmosphere, suppose you have a very dry atmosphere, so aqueous tension or water vapor in the atmosphere will be less. Atmosphere is less humid, it is dry. What happens? For an equilibrium to achieve, this crystal hydrate will lose water vapor to the atmosphere. It will lose water vapor and it become lower hydrate and finally become anhydrous. This is what happens. So this phenomena also depends on the atmospheric condition. So efflorescence happens in dry condition, whereas deliquescence happens in moist atmosphere, moist condition, wet condition, right? So in very moist atmosphere, even sodium sulfate may not effloresce because there is a lot of water vapor here, there is high vapor pressure, here. So the salt hydrate cannot lose water vapor to the atmosphere because vapor pressure is high above. So sodium sulfate and H2O may not effloresce even if the atmosphere is very moist. But if it is so dry, even copper sulfate 5H2O, which generally won't effloresce, but if the atmosphere is very dry, even copper sulfate 5H2O even may effloresce. So this deliquescence and efflorescence depends on the atmospheric conditions. So these two phenomena, deliquescence and efflorescence, are two opposite phenomena. In deliquescence, substance, crystalline salt absorb moisture from atmosphere and form and dissolve in it, whereas in efflorescence the salt hydrate lose water of hydration and become lower hydrate or anhydrous. That's all about solid gas equilibria in our syllabus. In the next class we will be discussing about the last section of this module, liquid-liquid equilibria. Thank you.